So I'm going to work out some of the problems from the homework here. So I'm going to start by taking the right-hand side here, which is a 2, and I'm going to go ahead and graph that. That, of course, is a horizontal line through y equals 2, so it should look just like that. And then the left-hand side is absolute value of x plus 4. So that, of course, is a V-shaped graph that is shifted left 4 from the origin. Remember, the main thing you want to make sure you include, since we're just looking to solve these, is you actually need points for where these graphs intersect, because ultimately that's your answer. So the solutions to this first problem are just the x coordinates. So they intersect at -2 and -6. If you graph correctly, you'll never get extraneous solutions when you use the graphing method. It's still a good idea to check your answer, though, in case you've made a graphing error. All right, so the next one. I'm going to graph y equals -3. Horizontal line shifted down 3 from the x-axis. And then the right-hand side is a V-shaped graph that's shifted up 5, right 1, and stretched by a factor of 2. We can see here pretty quickly that these graphs are not going to intersect. I'm going to go ahead and finish this one off, though. Still do need to graph the problem, even if you know it's going to be a no solution. Or, of course, we can say empty set as well. Number 3, this one looks like it will have a solution because the right-hand side, even after the absolute values by itself, is going to be a positive number. So y equals 5, that is a vertical shift up 5 units. This other one, it might be helpful to factor out the 2 first. Oh, and then there should also be a -3. That was not affected by the 2 that we factored out, but it does need to be included in the graph. So this is a vertical shift down 3. We're going to go left 2 of the origin and then be stretched by a factor of 3. We're going to have to graph several points. So we're going up 2, right 1, until they intersect. It looks like they intersect there. And it's going to intersect there. And again, I want to plot those points where they actually do intersect. Here are my solutions. So that's x equals 2 and -6. So what we got earlier, we got -2, -6 earlier. This time we got 2, -6. All right, then moving on to the back side. These they want us to solve algebraically. You must show your work for credit here. First one, the absolute value is already isolated, so you can go straight to splitting this into 2 equations. So we're going to set x minus 3 equal to 9, and then we're going to set x minus 3 equal to -9. Again, notice how we did not change anything on the left-hand side of that equation. So 12 and -6 should be the answers. Instead of actually writing out how I'm checking the solution, you can just kind of do it a quick check since it's pretty basic arithmetic. But 12 minus 3 is 9. Negative 6 minus 3 is negative 9. And the absolute value of negative 9 is, of course, positive 9. But don't forget, especially algebraically, is when you want to check the answers. Number 9, this one we do need to isolate the absolute value. So I'm going to add 3 to both sides first. And then we need to get rid of the 1/2. So instead of dividing both sides by 1/2, I'm going to multiply both sides by the reciprocal of 1/2. Of course, it's just 2. So that's going to isolate the absolute value. And now you can split it into 2. So our solution should be 10 and negative 18, but again, you want to make sure you're checking those answers. And then the last one is nice. They're going to end with an easy one because the absolute value is already isolated. Absolute value cannot equal a negative number. So this one is no solution, or x equals the empty set.